Okay, we're at Pierce Manifolds, Gilroy, California, home of one of the largest Weber inventories on earth. And today we're going to talk about the Weber DG series of carburetors. I've got 4 samples out here. The DFV, which is a mirror image of a DGV. We have a manual choke carburetor to look at today. We've got automatic choke carburetors, and we've got the 3838 synchronous carburetors. So I'm going to set these aside, and we're going to kind of go over some of the basics on the carburetors. People call us all the time, what does the 3236 mean? What does the 3838 mean? The numbers with a Weber carburetor are the diameter of the throttle blades, the throttle plates, the butterflies. They're called different things in different countries, but that's a 32 millimeter, that's a 36 millimeter, there's 38 millimeters. Anytime you get a number with a Weber carburetor, they're talking about the throttle blade diameter. The DG series carburetors are fixed Venturi carburetors, and on the body of the carburetor there's numbers in a circle, and those represent the smallest cross section of the Venturi. The one thing to remember about these carburetors, you cannot change the airflow. The airflow is fixed. The Venturis aren't changeable. About the only way you can increase the airflow to help performance is you can put an air horn on these carburetors, and on our super flow dyno, which is across the room, our flow bench, it does work. They do increase the airflow. Now the carburetor itself is pretty simple. It's a standard 4-bolt footprint. Goes on. In most cases, these carburetors are used in a plenum environment, which means one carburetor feeds the whole engine. 2-cylinder, 4-cylinder, 6-cylinder, 8 cylinders. It feeds out of a plenum. So the purpose of the carburetor, which only has one job, is to put a balanced air-fuel ratio to the engine from an idle to 10,000 RPMs. Wherever you're going, you need to get a balanced fuel ratio for it to work well. Okay, we're going to go around the carburetor here. These are the idle jet and idle jet holders on the primary and the secondary side. What does that mean? On a progressive 2-barrel, one barrel opens as the primary barrel. The second barrel comes in mechanically at a later point. That's a progressive carburetor. Unlike a synchronous carburetor, which has a gear drive and both barrels open together. So we're going to go around in a direction. This is the linkage, the progressive linkage, which you can see has a slip joint which opens and closes. The throttle stop screw is down here. This is a vacuum port that can be, this screw is removed and you can hook a vacuum up for an EGR valve or whatever you're plumbing. You have the mixture screw. You have another port that's plugged for another vacuum source. This is a ported vacuum for the vacuum advanced distributor. The choke unit, and while we're on the choke unit, the chokes can be, as we showed earlier, manual choke hooked up with a cable, or you can have an electric choke or a water choke. These are simply timing devices. It's a bimetal spring that's heated. If you were to take this carburetor and put the choke on it and set the choke and hook it up over here on the Weber bench and power it up, you don't even have to have a car. It will just turn itself off as the bimetal spring is heated with 12 volts and expands and turns the choke off. The water choke, obviously, water flows through it and the hot water turns the choke off. If you loosen the screws and turn the unit, it changes the tension on the flap so you can have your chokes come off sooner or stay on longer. It's fully adjustable. There's also a screw underneath that you turn for setting the choke speed. So when it's on the choke, you can set the idle speed. So getting back to the basics, the accelerator pump diaphragm unit, the fuel inlet, and on this carburetor it can be changed to either way, which is another point. Sometimes you'll get a DG series carburetor with more than one inlet. Some of them will have two, some of them can have three, usually set up for emission controls. The one coming in at an angle is always the fuel inline. This one happens to be a return line back to the gas tank, and even though that hole looks pretty big, if you look inside, it's a tiny little 1 millimeter hole, and when the float closes the needle and seat, it takes the pressure and returns it back to the fuel line, to the fuel tank. And that's pretty much the basics of the exterior of the carburetor. So I'm going to move a couple of things here, and instead of you watching me with a screwdriver take the top off of the carburetor, kind of like a cooking show, I'm going to the oven and grabbing one that the top's been removed so we can start looking at some of the internal components of the carburetor. These are the auxiliary venturis, the pump jet, the demand valve, air corrector jets, main fuel jets, power valve, needle and seat, and the float. The carburetors have the basic three functions of the jetting. There are the idle jets, which are removable externally. And the holder comes out, and then the jet is plugged into the end of the holder. That's the part you change when you're tuning, and they come in a wide range of sizes. And in the idle circuit, what you're looking for is the primary idle jet that puts your mixture screw in the operating window, which is somewhere between 3/4 to 1.5 turns out. When I mean out, that means when you set your car to lean best idle and you turn the engine off and you turn the screw in and count the turns in till it hits bottom, that's about 2.25. That's telling me that the primary idle jet is a little bit too small. So you step up to an idle jet size up, you readjust your lean best idle, and when you get this screw in the 3/4 to 1.5 out window, you've got the idle jet that your engine's asking for. The secondary on a progressive carburetor really has no idle circuit. There's no mixture screw over here. It's basically a progression bleed jet, and what it does is when you're driving with the second barrel partially open, there's progression bleed holes in the body that are exposed, and it gets fuel from this idle jet on the secondary side. On a synchronous carburetor, there's an idle jet on each side, an idle mixture screw on each side. So they do function on both sides. Just the primary side functions on the progressive carburetors. The main fuel jets are in the bottom of the float bowl, and all of the jets in a Weber carburetor have the size marked on them. Now I'm going to give you a little hint. We get hundreds and hundreds of calls a year when a customer calls and says, my car's running lean. I've got 120 main jets. I bought some 130s from you and put them in, and my car runs worse. Well, 9 times out of 10, someone's drilled the jet. It says 120 on it, so they buy a 130, and then when they go and buy, which is also available at piercemanifolds.com, the jet gauges, they find out that it says 120, but it measures 170 because someone's drilled it out. So when they went from 120 to 130, it's still so far below the 170 that it's drilled out to, they didn't get the results they were expecting. So it's not a bad idea if you have a carburetor that you don't know the history, you bought it on eBay, you got it out of the wrecking yard, you bought the car, it came on it, you don't know anything about it, to check the size of your jets. And it's real simple. There's a number on the gauge, says 150, the jet says 150, it fits. Go to the next one, it doesn't fit. You're pretty sure it's a 150. So the main jets feed fuel into the emulsion tube well, and this is the emulsion tube, and the air corrector jet meters the air into the emulsion tube well, with the combination of the emulsified fuel being fed to the engine via the auxiliary venturi, with the air passing through the auxiliary venturi and pulls the fuel out of the float bowl and feeds the engine in the main running environment. This is all changeable, all tunable. Too rich, too lean. One hint that we found, especially with today's gas prices, people are driving their cars, they've driven them for years, the way they got the carburetor out of the box, they're running a 140 main jet. Car runs fine. The question is, if they drop to a 135 main jet, would the car still run fine? And if it does, for the cost of a $4 jet, they've just picked up 3 miles to the gallon. It's not a bad idea to spend some time and dial your car in. The payoff can be tremendous. The next part of this thing is in the middle, and this is the Accelerator Pump Jet, which is controlled by throttle opening, the diaphragm inside here, which we'll look at in a bit, being depressed, pressurizing it, squirting fuel into the barrel, which, by the way, on a primary, secondary carburetor, it only squirts on the primary. We get lots of people that call and go, it's only squirting on one side, and it's like, yeah, that's right, because why would it squirt on a closed butterfly? And then they understand. The pump jet's held in with a demand valve, and the demand valve, you can see a lead plug in the top, and it rattles. When the ball is free and moving, it rattles. And what that does is when the engine comes up to high RPMs and the air is flowing through, the weight seals it off from siphoning fuel out of the pump jets. So you can get one that gets real rich on the high end and the ball's stuck, and it just starts a siphon of raw fuel. It's raw fuel. It's just there to give it a squirt. It's like a burst of fuel to keep the engine running smooth while the next circuit receives its signals from the engine and starts functioning properly. So the other thing we have here in the bottom of the float bowl, there's a power valve, and the power valve is controlled by a power valve diaphragm. When you turn the engine off, it defaults to the power valve being wide open. But when you start the motor and it's idling and the manifold vacuum is high, the power valve piston is pulled down like that, and the power valve is disengaged. In theory, what it does is when you give it hard acceleration and you need more fuel for like wide open throttle or a hard pull, the manifold vacuum drops, the power valve is released, it engages the power valve, and it gives a little more fuel to the main circuit. That's what the power valve does. The other thing is underneath this screen here, which we'll look at, is the fuel filter. Here we've got a carburetor that we've dismantled a little bit further, and we've got the accelerator pump diaphragm, the throttle shafts out, the throttle shaft seals. Another little hint, in the Weber world, these are inexpensive carburetors, and people buy the rebuild kits. And the rebuild kits are pretty standard. They have the gaskets, they have a accelerator pump diaphragm, a power valve diaphragm assembly, a new needle and seat. They do come with throttle shaft screws, the gaskets and the hardware to dismantle the carburetor and clean it and go through it. Sometimes the carburetors have been on the car for so long, since they do not have bearings, they get worn out, and you rock and it's sloppy and they're loose. And a hint on this, and I may have one right over here. When you take your carburetor off and you turn it upside down, if you look where, which obviously this is not a DGV, but it's just for a sample. If you look where the throttle shafts go through the body, and you see it's very clean. There's carbon and buildup, normal carbon and buildup, but right below the throttle shaft, it's really clean. That's because it's sucking air. It's constantly sucking air, making it lean, making it not run good. If you got a DGV to that point, buy a new one. Buy a new carburetor. To go through and ream these to oversized shafts, to buy the shafts, by the time you get done, the parts alone are within dollars of just a replacement carburetor. If you've worn one out that far, you got your money's worth. Get a new one and get back to driving. Which in the rebuild kits, by the way, there's always a nice exploded view so that when you go to put all this back together and you can't remember where something went, it's identified and you can get there. So here's a carburetor totally dismantled, and it's to the point of wanting to be cleaned, and everything cleaned and cleaned up with the best that you can. We actually use brake clean and blow through all the galleys because it leaves everything dry, it leaves no residue behind. Compressed air, and blow through everything once it's totally dismantled. You want to get a light, a good light that you can look in and look at the seats. Look where the jets seat. The jets themselves, let me find an idle jet here. It's like an idle jet has a tapered edge here that seats on a hole inside there. And it seals off that passage so that the metered fuel flows through the end of the jet. If the seat's bad or the end of the jet is bad, you can have a jet that says 50 that's flowing 300 on a bad seat. So you want to inspect the carburetor thoroughly. Look in the holes. Make sure that the seats look nice and round. I will take the idle jet holder and put the jet in and leave a gap. And then I'll take a common black felt pin, blacken the end of the jet. I'll screw it in until it seats. I'll take the jet out and make sure that my jet, the black felt marking, has a nice circular mark on it, showing me that it's seated fully all the way around. We've already discussed you want to check the throttle shafts and make sure that they're not loose and floppy. Make sure you don't have air track lines in the body showing that they've been leaking. Look at the mixture screw seat. That's very important. As the screws are put in and out over time, there's nothing to bottom them out. The spring doesn't coil bind, it reaches the bottom, and they just keep turning it, and they'll mushroom out the seat. I will blacken the end of the seats and make sure that I have a nice seat, that this is getting seated properly and sealing this circuit off. Go through the whole carburetor, look it over really good, and do that with the same thing. Do that with the top, and that you're going to be replacing. Which here's a bad one right here. You may not be able to see this, but there's a tiny little pinhole in that accelerator pump diaphragm right there, and that would be a vacuum leak. So the power valve would never disengage on this, which it should be disengaged in the idle and the low speed position. The diaphragms need to be, they're changed in the kit. These don't come in the rebuild kits. They last quite a while because they're They're not really exposed to fuel. That's the diaphragm for the choke pull off. And if it's nice and pliable, not torn, no holes, most of the time they can be reused fine. The rest of it, it's a matter of inspecting everything. One thing I forgot to mention on the primary, secondary carburetors, the jets will be different. And what I like to do is I'm dismantling it. I will take the main jets out, the air corrected jets, I'll take everything out of the primary side and keep it here, and everything out of the secondary side and keep it here. So when you go to reassemble it, you know what goes where, instead of going, oh gosh, I got a 135 main and a 140 main. I don't remember where they go. If you keep your carburetor divided in half and keep the primary side and the secondary side calibrated parts separate, it'll make it a lot easier for you. A lot of our customers, especially today, actually take digital pictures with their cell phone or whatever during the whole process, so they can refer back to, you know, where does this go, instead of, but it's an exploded view. If you're this far into it, you won't have problems. So the other thing I wanted to talk about while we're at this part is the needle and seat and the float assembly. Some of the carburetors have the float stand that's split. It's solid split. When you're working with these and you want to remove the float pin, you push from the split side and pull it out this way. If you push it the other way and you slightly cock this as you're pulling it out, it will snap this ear off. And then it's either replace the top or get someone capable of welding Zamac. And there's not a lot of people that can do that. So when you remove the float, and you remove the float, and you remove the needle and seat, and the needle and seats are in the repair kit, and the needle and seats have a calibrated range on them, there's a size marked on them, and it's in millimeters, which I never even mentioned that. All of the jets are in millimeters. If you have a jet, and this jet happens to say 160, that's 1.6 millimeters. That's the opening, the hole in it. The needle and seat, 2.0, 2 millimeters. Idle jets, 50 or 0.050 millimeters. So when you set and you put your new needle and seat in, and you go to adjust your floats, and you go to adjust the floats to the specifications, and they tell you that a brass float is 41 millimeters closed, 51 millimeters open. There's specifications for the plastic floats. With the carburetor top all back together, you roll the top over until the float rests on the needle and seat. You do not want it to depress the ball. You want it to just rest on the needle and seat, and you measure the gap from the top to the top of the float, and that's your float level setting. That's the 41 millimeters. When the carburetor is dropped from the top of the float to the bottom, that's your drop. That's the 51 millimeters. And you adjust this by bending this tab for the float level and this tab for the float height. As you can see, the clearance of the float in the float bowl is pretty tight. We get a lot of people that have run their car for so long. Let me see if I can quickly find it here. That the float fulcrum pin gets worn out. The inside of the float will get worn out, allowing the float to wobble. Too much movement. It should be nice and stuck, free, but not a lot of lateral movement, because you can have one of these floats that have so much movement this way that going around a hard corner, the fuel will push the float over and the float will drag on the wall of the carburetor. So check this out. Make sure this is a nice, snug fit, but very free moving. And the brass float, plastic float, that's a debate. A lot of people don't like brass floats. They say they have a tendency to get a solder seam leak and fill up in the sink. And a lot of people don't like plastic floats because they say that they'll absorb fuel and get heavy. And I just run whatever they came with. All right, at this point right now, here's my feelings. If what you've seen, with the help of just some simple, like the Weber tuning manual for the basics and stuff on the Weber carburetors, also available at Pierce Manifolds. The exploded view that comes in the rebuild kits, breaking everything down. What we've discussed here, you should be able to, number one, make the decision whether you should even be rebuilding your carburetor. Are the throttle shafts worn? Are the mixture screw seats bad? Are the idle jet seats bad? Is there so much corrosion in the bottom of the float bowl from water that, you know, is it a rebuildable carburetor? And then the other decision is, with what you have seen, if you're not ready to rebuild it, don't. Just buy one. Clean it up. Wash it off in a bucket with some soap and water or solvent or something. Stick it on eBay. Get $100 as a used carburetor. And so you're out of pocket to just get a brand new carburetor is less than $200. It's good for another 10 years, 15 years. Who knows how much you drive your car. That's probably the decision you should be making. So we're going to talk a little bit now about just, and it's going to be random, just some of the stuff that we run into all the time. 30 years of taking technical calls on DGVs on anything from Austins to Volkswagens and homemade deals and snowmobiles and Honda Gull Wings and gold panning gold dredges in Alaska with, I don't even know what the motors were, Wisconsins, and we made manifolds and put DGVs on them. We've had a gazillion questions, and probably the biggest thing is to realize it's a fixed Venturi carburetor. As we discussed earlier, this is about the only thing we have to get you more air through it. You can only get so much air through this carburetor. So whatever you're running it on, whether it's a 1098 Mini Cooper or a 2.2 liter Ford or a 2.5 liter Land Rover, this is a tough one to do. This carburetor technically is too small for a Land Rover because the primary 32 millimeter primary barrel, it's too small. It's pushing its limit at, I think, about 1.8 liters, but a lot of people put them on 2 liter cars. When you've got a carburetor that you're pushing the limits of the 32 millimeter primary barrel to have your low speed running drivable, we sell a sync link kit. And it's a linkage kit to synchronize the barrels, to open both barrels together. And it comes with the pump jet to get a squirt down both barrels. And it makes a huge difference in the drivability of larger displacement motors where the 32 millimeter primary barrel is just too small. And we sell tons of them, lots of the Toyota pickup truck, the Jeeps, the BMWs, the Land Rovers. It's real popular and real common. It's not difficult to install. The biggest installation problem that we see is people have a tendency to over-tighten this linkage. They get a wrench, they crank it down, they bind all this up so that right now both barrels are opening together, and this is just like a giant vacuum leak. There's no accelerator pump circuit to compensate for it. There's no idle circuit. The linkage should be free and smooth, and as you can see right here, if I take that nut and crank down on it, it'll bind this lever up and both barrels will open together, and we get lots of technical calls going, you know, I step on the gas and the engine dies, and We'll find out, we'll ask them, well, are both barrels opening together? And they'll go yes. And so we know what the problem is. We tell them to go back, take it all apart, lubricate it, and get it back to a primary, secondary environment. And they'll call back and go, oh yeah, it works great. That call is very common to us. We get idle jets, pump jets and idle jets that they're plugging up and they clean them and they plug them up and they clean them and they plug them up and they clean them. And one of the things that we found is the debris and the rust and steel lines in the fuel tanks are so fine, it'll pass through the filter that's part of the Weber system. Underneath this plug, there's the filter. And this filter, that fine stuff will pass through, but it won't pass through a 035 or an 040 idle jet. So when you take your carburetor top off and you see brown, fine, powdery rust debris in the bottom, you're passing debris from the gas tank. On the older cars, it's real common. The obvious fix is to replace the tank, replace the lines, figure out where the problem is. But one thing that we have found is we've brought these fuel filters in out of Italy, which looks like a standard fuel filter, but it's made for fuel injection. It's one of the only fuel injection filters that we've found that use a standard hose line. So it can go right in line before your carburetor, and it will keep that fine debris out that will go right through the Weber factory filter. When these things get plugged up, I happen to have an MGB with a bad tank. When it quits running because it's plugged up, this thing weighs 5 pounds. You can't believe how much debris this will hold. Okay, we're going to kind of look at this poster here so you get a little better understanding of why some of this stuff has to be the way it is. This is irrelevant to us. This is a cold start unit for DCOE. We don't have a cold start unit. These carburetors have electric choke, water choke, manual chokes. It's all operated, and we went over that. The idle circuit and the progression circuit. And we talked earlier about the position of the mixture screw being so important. And basically, if we take a look at this, I'm no artist. I'm drawing the throttle bore. This is the wall here. That's a progression hole, a wall, a progression hole. This is an idle mixture screw coming through, and the wall again. And the fuel is flowing this way, and the fuel is flowing all the way around the mixture screw. That's what your car is idling on. This is where your idle mixture screw gets set. As you step on the gas and the throttle blades move, they expose these holes. This blade's going to come up like this, and then eventually it's going to come up like that. And when they expose this hole, the throttle blade is obviously moving because it's swinging in an arc further away from the wall, allowing more air, needs more fuel to balance. So it starts pulling fuel on this corner. The fuel has to turn this corner. If your mixture screw is outside of the window like that, the fuel flow through here is tremendous. So when the butterflies expose the progression hole, it won't turn the corner. Your progression will go lean because the mixture screw is so far out, and fuel is fluid and it takes the path of least resistance. So you run into a lean hole here, and it's just the opposite. If the mixture screw for your lean best idle is so far in, there's just barely an opening here, the pressure buildup here, as soon as it exposes these progression holes, it just dumps gangs of fuel, way too much. So in order for your progression circuits to work, your mixture screws in the operating window, and that's the 3/4 to 1.5 turns out. So In your initial tuning, just for the sake of conversation, you went to the wrecking yard and you bought a carburetor, or you bought a new carburetor, and there's no jets in it at all. You have to find the mixture screw that gets your mixture screw in the operating window. You're done. Your idle circuit, your progression circuit are done. The one thing that becomes an issue is if you're running an engine it's got a cam and it's got a header and it's overboard and the performance is way up there, and you're too cheap to buy a twin DCOE conversion, which we have, by the way, you're going to try to hang in there with your DGV. It needs more air than the carburetor can give it. There's no way for the engine to get air except what leaks around the butterflies. They're not watertight. They leak air. That's the air for idle. You open the throttle and you turn this screw in, and you can turn it in just a hair. But I don't know if you'll be able to see this, but when you barely move it, you expose the first progression hole. If you try to idle with the first progression hole exposed, they won't idle down. You let off the gas, and instead of coming back to a crisp idle, they bleed fuel, the idle hangs up, the RPMs drop really slow. We found there's two possible ways that we've come up with doing this. Sometimes you can take the idle stop screw for the secondary side and crack it a hair. I mean, not a turn, a part of a turn, allowing you to just get a tiny bit more air in there. Otherwise, you expose the progression hole. So sometimes you can kind of cheat the system on a big motor, a hot rod motor. You can get a little bit more air by cracking the secondary butterfly and the primary butterfly a tiny bit. You go too far, you'll know it. The other thing that we've done, and we've cheated the system, is to get these throttle blades back into the home position, and we'll drill a 1 millimeter hole in the butterfly opposite the progression holes, allowing some air to get through that hole to idle the engine, because you really can't rely on this for your idle speed. Technically, this should be closed. It's a stop. It's not really a speed screw. It's a stop, so that when you back off the throttle, the linkage hits the head of the screw instead of wearing a groove where the butterfly hits the bore. So try to keep in mind, if the engine's saying, I need more air, sometimes you got to figure a way to get it, because if you try using this screw to get it, they don't run right, because the progression holes will be exposed and they just start dumping too much fuel. So you want to keep your idle mixture screw in the operating window. That is important. The accelerator circuit is pretty much the accelerator pump diaphragm being moved by the linkage. There's not much you can do to change that. We have had people increase it by doing things like they'll build that cam up a little higher and get a little more pump squirt. These are some of the real guys that are just really into tuning these things. A fresh diaphragm helps a lot. And by the way, with today's fuel, with the additives, and the fact that today's fuel is designed to never be exposed to the atmosphere, guys don't drive their cars all the time. They're atmosphere vented carburetors. All the fuel evaporates, the diaphragm gets dry, then it gets wet, then it gets dry. I don't have but a couple of cars that I own that have got these type of carburetors on them. I change the diaphragm every year. It's like, it's $10, put a fresh one on it. I don't take any chances. But the diaphragm's in good shape. The demand valve we discussed is in good shape. The ball rattles freely. You can increase the size of the pump jet. It's a calibrated part. There's a number on it that's in millimeters. You can put a bigger pump jet, put a smaller pump jet in it. The other thing to make sure is there's no debris in the system. When you hit the throttle with the engine not running and you hit it, it should be a squirt, a stream, not a little bubbly dribble. And if it's a bubbly dribble, check your diaphragm out, check your demand valve out, take the top off, clean the passages, make sure you're getting a good pump squirt. So the main running circuit of the carburetor, like in this drawing here, everything is engaged. And basically, we're talking about the whole calibrated, the whole package. The throttle blades are wide open. It's got maximum airflow. The main jets are dumping the fuel into the emulsion tube well. The emulsion tube is emulsifying the fuel. The air correctors are dumping the air corrector in. Everything is being fed through the auxiliary venturi. The question is it too rich or is it too lean? And there's a tremendous amount of data out there available on whatever you're driving. If you're driving a Morris Minor pickup with a DGV on it, there's lots of data telling that, they normally run a 125 main jet and F6 whatever the calibrated parts are. That's the information that's available gives you the ability to buy a carburetor from somewhere and get it close to a starting point. But don't forget to dial it in. The standard rule of thumb, run the smallest amount of fuel that'll make your car run well. And play around, downsize the main jets until you get too lean, step back up into it. It's a minor investment in calibrated parts. It can be a minor investment in your time to do all this, but the end result is if you can find 7, 8, 9 miles to the gallon, doesn't take long to pay for $30, $40 worth of jets. The other thing that I wanted to go over real quick was, we talked about the float level and setting it. The float level in the float bowl establishes the fuel level in the emulsion tube well. So if your float level is a couple of millimeters too high or a couple of millimeters too low, the whole car can run a little bit rich or a little bit lean. We get people that call here several times a week trying to get their carburetors technically. They want assistance, they want some assistance, they want to get them dialed in. And our first question is, did you set your float level? And people tell me, oh yeah. And so I'll immediately fire back, so what'd you set your float metal, about 7 inches? Yeah. Well, obviously, how are you going to get 7 inches out of that? They haven't checked their float level. I don't know why they insist on saying they have, and so we just say, look, if you're not going to give us the straight skinny, we can't help you. Get your float level checked, call us back, and then they'll go through the process. And the float level and instructions are on our website. There's lots of data available. It's important to set your float level. The other thing that's important is fuel pump pressure. These carburetors like 3 to 4 pounds. You get on the gas, you run down the road, the car runs great, it gets up to 4,000, 5,000 RPMs, and it flattens out. And you have a tendency to want to go, if you have a regulator, raise the fuel pump pressure. You can't. If you push the fuel pump pressure up into the 5, 6 pound range, the pressure on the needle and seat sinks the float. You change it by changing the needle and seat size. If you have a 150 needle and seat and it needs more fuel, go to a 175, a 200, a 225, a 250. You don't change your fuel pump pressure, you increase the needle and seat size if the engine demand is there. A lot of people right now are going, why don't I just go to the biggest there is? Again, when your float is closed, especially in a cornering situation, and you level the car out and the float drops and you've got a 3.0 needle and seat, it dumps too much fuel, overfilling the float bowl. You want to run the smallest needle and seat size that'll pull your top end. It's the standard rule of thumb. So just in case you really want to do it right, you can put a fuel pressure stabilizer in line, also available from Pierce Manifolds. And what this does is it takes the line pressure and stabilizes it. When the needle and seat opens and closes, it keeps the pressure the same at the carburetor, even though, as we all know, that when the needle and seat closes, the stacked pressure of that 4-pound pump can stack up to 5 or 6 behind the needle and seat. This stabilizes the pressure dump to the carburetor. They work well. We've had great reports of drivability improvements and gas mileage improvements. It's not a power part, doesn't make any horsepower. I think we'll just kind of finish this up by going over a little deal here and just kind of summarize what we're talking, the different calibrated parts that are available and the range of them. We've got the needle and seat, which is a calibrated part. You can adjust your fuel volume demands with the needle and seat. Rule of thumb, run the smallest that will do the job for you. The emulsion tubes are a little bit complicated. Most of the information is available. Most of the carburetor kits that we sell have got the emulsion tube in that's generally had the best results. Guys that are really into tuning can play around with emulsion tubes. There's a lot of data in the tuning manual. They have cutaway views. They have some rich and lean charts for emulsion tubes. They have a cutaway of every emulsion tube, the hole placements. There's some good reading in here, and you know, you really want to dial it in. You can play around with the emulsion tubes, but the emulsion tubes, in conjunction with the air corrector jets, which the air corrector jets flow air. Bigger the jet, the leaner. That's just the opposite of all the other jets in the carburetor. If you want to lean it out, you put bigger air correctors in. And the other thing to keep in mind is the air corrector jets mainly affect the last 25% of your RPM range. So if you had a 4,000 RPM motor, your air correctors do most of their work from 3 to 4,000. So you can figure that out from if you got a 12,000 RPM motor. They correct the fuel curve, rich and lean, on the top end. Your main jets correct the fuel everywhere after the progression jet is through. So after progression, the mains engage, your fuel comes in from your mains, your air comes in through your airs, they get to the emulsion tube well, they're mixed, they're fed through the auxiliary venturi to the engine in an emulsified mixture, and this is determined on the airflow through the carburetor. The harder you push the accelerator down, the more the airflow goes up, the more fuel it delivers in an emulsified mixture. The idle jets control the idle circuit, and they control the idle circuit on the primary side with a mixture screw. We talked about getting the mixture screw in the window. And on the secondary side, the idle jets control the fuel through the secondary progression holes because there is no idle circuit on the secondary side. Everything we're discussing revolving around genuine Weber carburetors, and to our knowledge, every Weber carburetor that's a Weber carburetor made in Bologna, Italy, or Guadalajara, Spain, if it's a genuine Weber, the Weber logo, the Weber name, they're cast on the carburetors. We do see some carburetors out there. We've seen carburetors that are marketed as Webers. We've seen carburetors that look like a Weber. And we don't know if the information we're giving has any bearing on those carburetors or not. They look like a Weber. We've never dissected one. We're not positive how the circuitry works. So If you're working with one of those carburetors and something we're telling you to do doesn't work, I don't know what to tell you. Again, this is a very current carburetor. It's only been in the building for a couple of weeks. Weber W, Weber name, Weber. All over this carburetor, it says Weber in the castings. It's cast on the product. Even if I wanted to call this carburetor a turnip, it still says Weber. All right, before we close, I wanted to just go over a couple of items that we sell here. Float leveling gauges for the DGV series, both plastic and brass. They're pretty inexpensive, they're very accurate. A lot of people feel more comfortable if they have a tool instead of a ruler. And this is probably the greatest tool that we sell to help us help you. We carry the AEM air-fuel ratio meters. It's a complete kit. It's got the 5-wire O2 sensor, the weld-in bung, all of the plumbing and hardware, great instructions. It reads instantaneously, both analog and digital, and people call us and tell us what's going on. I'm going up a hill and my air-fuel ratio changes and it goes from 13.2 to 15. You know, it's a great tool. It really helps you dial your car in. Every Weber car in America should have one, and they should buy it from Pierce Manifolds. All right, so you've seen a lot of information, you've seen a lot of parts. Probably at this point right now, if you haven't been on our website, piercemanifolds.com, go there, spend a few minutes, search around, and it'll be a lot of help, as I hope this video has been a lot of help for you also.